Hello guys, welcome back to the channel. In this tutorial, you will learn how to assign correct geographical properties to an image. Well, in short, how to georeference an image in AutoCAD. Now, it's quite important to understand that when working with a standard Cartesian coordinate system in AutoCAD, if you just happen to open a new drawing like this, your XY coordinates are basically defined relative to the origin, which is 0, 0 coordinate on a 2D plane, which is typically placed on the lower left corner of your drawing. Right over here. So as you can see, when I move my mouse pointer over here, you can see that the X value increases, and if I were to just slide my mouse pointer vertically upwards, you can see that the Y value increases accordingly. So if you were to consider an image which needs proper attributions in terms of having correct coordinates, the general idea would be to obtain the XY coordinates of at least a few known points, and after importing the image into AutoCAD, we can then swiftly try to align the image in such a way that those known points end up getting placed exactly on those respective XY coordinates on your AutoCAD canvas. That means when we manage to sort of import an image to a totally random location on our drawing canvas, we can just go ahead and realign the image or move the image on the Cartesian plane to make sure that those known points of the image end up getting placed at the correct XY coordinates with respect to the origin. Now, to extract the image as well as to create these non-reference points, I will be using a free and open source GIS software package called QGIS. It's a software that you can download absolutely for free, and we're going to use QGIS just on the surface level, so even if you have no experience on how to use QGIS, you still would be able to follow along without any issues. Alright guys, so I'm just going to go ahead and open up QGIS, and there may be multiple ways of extracting an image in QGIS, but for the purposes of this tutorial, I'm going to use a plugin called Quick Map Services. In case if you haven't installed this plugin, you can install it completely for free if you head over to plugins and select manage and install plugins. From here you would be able to search Quick Map Services. It's this one right here. And in your case, if you're doing this for the first time, there will be an install button right over here. But in my case, since I have already installed this plugin, I'm not going to do anything further than this. So once you have done the installation, it's going to appear under this web Quick Map Services. And you can head over to OSM and click on OSM Standard. Alright, afterwards you need to decide which geographical region that you're actually trying to work in. Now in my case, I'm going to zoom into this region of Brazil, which is next to the capital city, and I would like to export this image into AutoCAD. So just to refine the extents of your view, what you can do is you can head over to this zoom in button, and after that you can just sort of demarcate the boundaries in this kind of a manner. Also you can use the scroll wheel as a button to sort of pan this view around. Alright, since we're talking about georeferencing, it's quite important that we are aware of the coordinate reference system that we are working in. Now, for example, if I hover my mouse pointer over here, you can see that at the bottom, some sort of a coordinate reference system has been actually applied, and both the numbers appear to be negative values. However, until now, I haven't really checked which coordinate reference system has been assigned to my map automatically, and you can check that by heading over to this button right over here. And you can see that the current coordinate reference system is S3102100 WGS 1984 Web Mercator coordinate reference system. Now in your specific case, it could be a geographic coordinate reference system or a projected coordinate reference system. But just for the purpose of generalization, I think I'm going to use a UTM coordinate reference system for the purpose of this tutorial. That means I'm going to find out the corresponding UTM zone that's covering this part of the world, and I'm going to change this coordinate reference system to match that. And how exactly can you find the corresponding UTM zone? You can actually use a map like this. And if I sort of zoom into my area of interest, you can see that it's belonging to this UTM zone 23, and we're in the southern hemisphere, so it's going to be south. So what we can do is we can head over to this button and search UTM zone 23S, which indicates the southern hemisphere. And right over here you can see that under the projected coordinate reference systems, we can scroll down and select WGS 1984 UTM zone 23 south. So it's basically covering this part of Brazil as indicated right over here. And after I click apply and click OK, now you can see that the coordinate values actually changed. Now both X and Y values are positive. So you can see that when I hover my mouse pointer horizontally, the X value changes, and when I do it vertically, the Y value changes. So this can be considered basically as X and Y coordinates. Alright, so the next task would be to create a few reference points that we can use to sort of identify or sort of extract the exact coordinates at different locations of this image. So the easiest way to do that would be just to create a shapefile, a point shapefile, maybe with around 3 or 4 points. And I'm planning to place those points somewhere at the edge of the screen, because later on when I export this image into AutoCAD, I'm going to export the image along with those points, but as long as I keep it towards the edge of the image, I can just crop them out once I'm done with the process of georeferencing. So let's go ahead and create a new point shapefile. And if you're not really familiar with creating a new point shapefile in QGIS, you can just follow along. For example, from the browser panel over here, you can just head over to a specific folder in which you would like to save your shapefile. After that, you can right click, go to new, and we're going to create a new shapefile. So I'm going to name this as reference points. And of course, the geometry type is going to be point. And we're going to have to match this coordinate reference system with whatever the coordinate reference system that we chose right over here. So it's going to be this EPSG 32723. So I'm going to search for it. That's going to be this. And after that, I can simply click OK. And you can see that an empty file got placed right over here. So if I double click, it'll come to this layers panel as an empty shapefile. So all I have to do is just right click over here and toggle editing mode. And after that, I can click over here on add point feature. And that's going to enable this option to add any number of points that you want into this shapefile. So let's say my first point, I'm going to place it somewhere over here. And I'm going to name that as 1. The second point will be at this corner. Make that to be number 2, and this one to be number 3, and the final point to be number 4. Alright, so just like that, you can see that we managed to create 4 different points, 1, 2, 3, 4. And once you're done with creating the points, you can just click on this button again to sort of save the changes and exit from the editing mode. And I would like to change the appearance of these 4 points. Let's go to properties, and under symbology we can go to simple marker. And since we're trying to sort of pinpoint to the exact point, I think in this case I will go for an icon that looks something like this, so that I know the location where these 2 lines are crossing would be the exact point that I'm supposed to be referring to. And you can of course increase the size and maybe increase the thickness of this a little bit like this. Yeah, I think that's good enough. And after that, we can click OK. And I guess now we're done with the image itself. So just to export this image, what we can do is, well, there's an easy way of doing this. You can just take a screenshot and save it as a JPEG file. But I would rather just go to project and create a new print layout. Let's just call this as map and click OK. And after that, I can click over here on this add map button and just draw the map like this. And you can see that the image got placed perfectly. However, if you would like to shift things around just a little bit, you can click over here on this item properties tab and make sure that you click over here on interactively edit map extent. And after that, you can sort of move this around like this. But I think by default, the fitting was quite alright. All I have to make sure is that I get these 4 points or these 4 crosses within my map canvas, because those are the 4 reference points that I'll be using. And once everything is done, you can just head over to layout and export this as an image. You can choose a number of different image formats. I'm just going to go with JPEG, and let's call this map 1 and click OK. And from here you can choose the export resolution. Well, 300 dpi is actually quite high resolution, so I'm just going to keep that as default, and we can just go ahead and click save. Alright, now if you head over to the folder itself, this is how that image is actually going to look like. If you double click over here, it's going to get opened up like this. You can see that we still maintain the 4 crosses on the sides. Alright, now what we can do is we can minimize this for the time being. And my next objective would be to export these 4 crosses. Because it's a shapefile, we have the possibility of exporting these 4 crosses in a way that it can be imported into AutoCAD while it's maintaining its spatial reference properties. For example, you can see that when I take my mouse pointer over here, I think what I can do is I can just zoom in like this. Whatever you see over here are the XY coordinates of this particular point, and the same goes for the other points as well. For example, if I were to zoom in to this point and place my mouse pointer over here, what you see at the bottom of the screen are going to be the XY coordinates of this particular point. However, we don't really have to worry about noting down anything because this file itself is a shapefile. So I'm going to export this file as a file that can be read using AutoCAD. So we'll go to Save Features As. And after that, quite important, make sure that you select the format to be AutoCAD DXF, which is the file that's going to be read by AutoCAD. And of course, you can just go ahead and give a name. And I'm going to name this as 4 reference points. And the file type is going to be DXF by default. Click on Save. And then click OK. Right now you can see that a new file got created over here, and if you head over to the actual folder itself, you can see the DXF file which got created for ref points, and this file is actually something that can be read using AutoCAD. So all I have to do is just open that file directly, and at the first glance you might not be able to see anything. The reason for that is that your zoom extent might be quite different from the actual geographical location of those points on your AutoCAD canvas. To zoom into the extents of those 4 points, what we can do is just hit Z, and that will activate the zoom command. After that, down from here you can select how you would like to do your zooming, and in my case I would like to zoom to the extents of the 4 points, and that'll kind of zoom you into the extents of the 4 points. Well, I'm not so sure whether you guys can clearly see the 4 points or not, but in my case I do see the points even though it's not so clear. But we can change the appearance of these points by using the command ptype. And of course we are going to go with this kind of a representation, and I'm going to change this to be set size in absolute units, and maybe I will change this to be about 20, and then click OK. Yeah, when we do that, you can see that the points actually got changed to a representation like this. And at the same time, if you check the corresponding coordinates at the bottom of the screen, you can see that it's quite similar to the coordinates that we saw in QGIS. Well, just to ensure that I have put the 2 screens side by side, so let's say if I were to zoom into this top left point, you can see that the corresponding coordinates are supposed to be something like 675252, 748, 1282. And if I do the same over here in QGIS, you can see that the corresponding coordinates are actually exactly the same. Well, technically it should be the same. Maybe if you would like to increase the size just a little bit more, maybe I will use the ptype command again and increase the point size to be about 40. I think that way it'll be more clear. And you can change the color of these points simply by heading over to this layer, and if you click over here you will be able to change the color to be something like this. Yeah, I think now it's more visible. And before proceeding further, if you would like to save this file maybe to a separate DWG file, you can just head over to this A button over here, click Save As, and I'm just going to name this as test and save. And now it's saved as DWG file, as you can see over here. Alright, so to import the image, what we can do is we can head over to Insert tab, and from here select Attach. And after you navigate to the folder that you saved your map, it'll appear something like this. So I'm going to select that map and click Open. These properties, I'm going to leave everything as default because we are going to make the changes manually in any case. So we'll click OK over here. And when you place the image, it'll be better if you just try to frame the image in such a way that it's kind of capturing all of these 4 points, so that later on when you try to align the image to the correct location, it'll be easy to move it around. So to insert the image, what I'm going to do is I'm going to go a few meters away from that boundary, and I'm going to place my image somewhere over here. And I can make sure that I place my image in such a way that it's sort of going to engulf the 4 points. Well, there's no hard and fast rule of doing this. It's just my preferred way of doing it, because later on we are going to change the alignment of the image anyway. So let's click over here to confirm this. And now you can see that the image got placed. However, now there's an issue. We cannot see the pink color crosses anymore. So what we can do is we can select this image. So to select the image, you can click over here on one of these borders of this image, and that'll select the image. Right click and go to Draw Order and select Send to Back. And that'll sort of send this image behind these pink color crosses that we had previously. Alright, so now the basic idea would be to sort of realign and rescale this image in such a way that this cross will match the exact geographical location of this point, and this cross is supposed to change to this point, and similarly this cross will have to be placed at the location of this point, and this cross will have to move to this point. So in doing so, you can imagine that there's going to be some sort of a rescaling of the image that's going to be necessary. And at the same time, there's going to be some realignment that's going to be needed as well. So the tool that we are going to use to change this image is called Align, which you can find under this Home tab. If you extend this Modify panel, right over here, you can find the Align tool. So if I click over here on Align, you can now see that we are asked to select the objects that we are trying to align. So in this case, the object that we are trying to align will be the image itself. So I'm going to click over here on one of these sides of this image. And after that, we can hit Enter. And now we can start specifying the source points. So the way to specify the source points would be, we're going to select approximately the midpoint of this cross like this. And we are going to map that to the midpoint of this cross. So the first source point is created, and then I'm going to head over to maybe a point that's a bit far away from the previous point, which in this case would be this. So I'm going to again create the second source point at this location and map that to the midpoint of this cross. So we can also go ahead and create a third source point, but if you think that this is sufficient enough, what you can do is you can just hit Enter, and it'll ask you whether you would want to scale the objects based on the alignment points or not, and you can say yes. And just like that, you can see that the image got rescaled and realigned in such a way that this cross is now exactly at the midpoint of this pink color cross, and this one has moved accordingly as well. And along with that, you can see that the cool thing is that these other two crosses have also moved to the correct location when we did the rescaling and realignment. And with that, guys, you can consider this image to be properly georeferenced, because now if I take my mouse pointer over here to this point, you can see that coordinates are actually going to be exactly what they're supposed to be. That means now this image has been placed at the correct coordinates in this XY Cartesian plane. And for this particular case, the coordinate reference system that we are referring to is the UTM Zone 23 South coordinate reference system related to these numbers that you are seeing over here on the screen. Alright guys, now it's pretty much done. Now if you would like to get rid of these points, you can do that as well, simply by selecting the points and deleting them. And just like what I mentioned to you guys at the beginning of this tutorial, now you can even just crop these 4 crosses out because you won't be needing them anymore. And by cropping this image, you're not going to move this image on space. You're just going to get rid of the sides of this image so that these 4 crosses will not be visible anymore. So for that, what you can do is simply select your object again and head over to create clipping boundary. And from here at the bottom, we can select how we would like to clip. I'm going to select rectangular so that it'll let me sort of draw a rectangle maybe from here up to here in such a way that I don't include the crosses, the four reference points anymore in my image. So if I were to draw my rectangle like this, you can see that now it got cropped and only the part that's relevant remains just like this. Alright guys, that's pretty much it. That's how you sort of shift an image on this AutoCAD drawing plane in such a way that it finally ends up at the correct geographical location. And that's what we ultimately call as the image having been georeferenced. Now I could wrap up the tutorial at this point because whatever we wanted is now done. But I'm not going to do that. I'm going to do a final test just to make sure that this image got georeferenced properly in AutoCAD. And the best way to check that would be to head back to QGIS. I'm going to maybe minimize this mapping window. Now let's say if I were to create a couple of objects by means of digitizing over this, and if I were to transfer that over to AutoCAD, it should get placed exactly at the correct location, isn't it? So that's one of the best ways of actually checking whether your image got georeferenced properly or not. So just for the sake of checking, what I'm going to do is I'm going to create some random polylines in the form of shapefiles, and after that I'm going to convert that into a file that can be read using AutoCAD, and I'm going to import those geometrical objects onto this drawing canvas so that spatially it should get placed exactly where it's supposed to be. So you can follow a similar procedure to create a couple of geometrical objects. I'm going to right click over here and go to new shapefile, and this time I'm just going to name this as random shapes, and let's go with line objects. And quite important, you have to change the coordinate system again to be the correct coordinate reference system, which in this case this WGS 1984 UTM zone 23S. Alright, click OK, and you have to double click this random objects or random shapes shapefile in order to add that to the layers panel. And after that, right click over here to toggle the editing mode, and finally you have to click over here to add different line features. Let me go ahead and create some random line features like this, one from here to here, and I'm going to name this as 1, and maybe another line that's sort of going along this road in this manner. Again, this is something that you don't really have to do. I'm doing this just for the purpose of checking to see whether the image got georeferenced properly or not in AutoCAD. Once you're done, just right click to conclude. Yeah, after that I can click over here to save the edits, and if the lines are not too visible, maybe I can change the color to be blue and change the stroke width a bit as well, like this. So you can see that I have digitized these lines in QGIS. So when I move this over to AutoCAD, it should get placed exactly on top of this rod and on top of this gray color thing that you can see from here. What we can do is we can save this as a file that can be read using AutoCAD. That's going to be a DXF file like this. I'm going to name this as random shapes and click save and click OK. Alright, now we can head over to the actual folder itself, and it's going to be this file, random shapes. So I'm going to open that file, and again I will have to zoom to the extents of the objects. Yeah, so that's going to be these two objects. And what I can do is I can save this file as a DWG file as well by going to save as, and still will be randomshapes.dwg. You can see the file format over here is DWG. So let's go ahead and say save. And now what you can do is you can select both of these items like this, and then click Ctrl+C, the command for copying. And after that you can open the test DWG file in which we have this georeferenced image. And after that you can type the command paste orig. Well, what happens with this paste orig command is that the objects are going to get pasted in this new drawing space with the exact same spatial coordinates of its source. And that's what we want. So I'm going to hit paste orig. And just like that, you can see that the lines actually got placed exactly where they're supposed to be, just like how I digitized them in QGIS. And that's additional proof to justify that this image is now properly georeferenced in terms of its X and Y coordinates. Alright guys, that wraps up the tutorial. I hope the tutorial was helpful for you guys. If you do have any questions, you can add a comment down below. And you can always show your support by hitting that like button if you do like to see this kind of content on this channel. So thanks a lot for watching guys. I'll see you again in another tutorial very soon.